Hello, welcome back. My name is Darren Thomas, and I am the Director of Educational Research Techniques. In this particular video, we're going to be looking at fraud detection with Python, and we're going to learn how we can use logistic regression to make that happen. Let's go ahead and see what we can learn. So we're not going to go over the details of how logistic regression works. That is beyond the scope of this video. We have other resources available where you can check that out and learn how logistic regression works. But what we're going to do is logistic regression is great for when you have a categorical dependent variable. That's what we're really going to focus on. And so for us, our dependent variable is going to be whether it is fraud or not fraud for that particular case, as an example. So let's go ahead and take a look at the libraries you're going to be using. So we got lots of little tools that we're going to be using here. We're going to be using, of course, NumPy and Panda for data preparation purposes. Excuse me. Then we're going to be using logistic regression, of course. That's going to be for our model. We have to, of course, make our train and test split. So if you're familiar with the basic steps of machine learning, making a train and a test set for the purposes of training your model. Again, the details of that is beyond the scope of this video, but that's what we're using that for. And of course, we're going to be making our confusion matrix, which gives us kind of like a visual. And we're going to have our classification report, which will give us our precision, recall, F1 score, etc. So we're going to go ahead and run this. Of course, there's nothing to see with that. And of course, down here, what we're doing here is we're loading our data as DF. Of course, this right here is an object that has the actual location of our data saved. And of course, this is not readily available on the internet in terms of the actual data. So next, we're going to go ahead and do our preparation. It's not really all that complicated. First, let's just take a look at what we have in case you have not seen the prior videos. So this is what we have right here. This first row or this first column is kind of like an identifier, so we're not going to use that information. And then after that, we have variable 1 all the way to variable 30 or 28, I believe. And then we have amount and class. Class is our dependent variable, whether the case is fraud or not fraud, so 0 or 1. So all these variables, they have no real meaning to them. This is kind of like fictitious data that helps you for practicing. But this is what we have in terms of our variables. So you can't really do an interpretation of, okay, this variable means this, because they don't really have any names to them. Now next, what we're going to do now is we're going to separate our X values and our Y dependent value. So if you look at this code right here in our next little row here, what we're doing is this. We're taking everything from row 1 all the way to row 30, or excuse me, this will be up until row 29, excuse me, and we're going to put those as our X values. That's what we're doing right here with this first line of code. And then once we take that, we're going to set these X values as an array using the .array method with NumPy, and we're going to make it a data type as a float. And then we repeat this process where we take just our Y value, which is going to be row number 30 itself, and we also convert it to an array as well. And so remember with NumPy, it has a 0 base index. So when we're going here, we're going from, basically row 1, or you could say row number 2, basically, because there's a 0 row, all the way up until row 29, because you don't include this last number here. And then for this one, since it's only one column, actually these are all columns, by the way, sorry. Since these are a column, we're just taking the 30th column. The stuff before the comma means take all rows. So this is all take all rows, comma, and then we limit the columns we're taking. So column 2 to column 29, basically, and then we're going to take column 30 in this one. That's what's happening. So let's run this, make sure we do that. Now we're going to take a quick peek at what we have. Oops, got to capitalize that. So this is our X object right here, and then we have our Y object. Notice how it's pretty much just the one vector because this is our dependent values. Now we're going to create our train and test sets. Again, this is just pretty much one line of code. but I'll walk you through it, keep it nice and simple for you. All right, so what's happening over here? We are creating 4 objects at once. X train, X test, Y train, Y test. And we're using this function right here to do it. And we are pulling, or we're taking the values from the X object and the Y object we just made. And what's happening is this. 30% of our data is going to be set aside for training. That's what 0.3 means, or excuse me, for test. 30% of our data is going to be set aside for testing. That's where that 0.3 comes from. So of all of our X values, 30% are going to go here in our X underscore test, and then 30% will go here, Y underscore test. The remaining 70% will go into our X underscore train and our Y underscore train. And the random state argument right here, that's just the way to set your seed in case you want to reproduce these results. So we're setting our seed to 0. Let's go ahead and run this. All right. Now we can start going through the process of fitting our data. Okay, so the first thing we do is we create an instance of our logistic regression function here, and we name it as model. This max iter equals 1000. This argument, this is to make sure that our model converges. Again, the details of that are beyond the scope of this video. But sometimes if you don't set this, you'll get error messages. Then we're going to fit our model. So we take the object that we made right here, and we use the .fit method on it, and we take our X train data and our Y train data. So we're training the model right here. Then we want to make our predictions. So now that we have a model, we predict with it, and we use our X test data right here. Now, remember, you can only use your test data once. We're going to learn more about that in a second. But, this is just going through the process. We're not following all the rules. If you want a more robust way where you can kind of retrain the model using the same data, that's where you can use cross-validation, k-fold cross-validation as an example. So we run this, and there's nothing to see yet. We're just running it. So we have some values here. And so just so you know what the predicted looks like, we're just going to go ahead and take a look at this. You can see it's an array with, pretty much, a vector basically. Now we get to some of the cool stuff here. We're going to run our classification matrix in our classification report in our confusion matrix, excuse me. So right here is our classification report. It'll give us values such as our precision, recall, F1 score, and our accuracy. And then we're also going to make our confusion matrix so we just kind of get a visual of our data set. So let's run this. All right. So here are our values right here for precision and recall. You can see looks pretty good here. This right here tells you how well it is at predicting when something is fraud. So you can see pretty good here. A precision of 0.9 or 90%, recall of 0.90, F score of 90% or 0.9, 90, excuse me. Then you have some macro averages at the bottom and weighted if you decide you need to know that. And so it looks like we're pretty good at dealing with true positives, false negatives and false positives as well. Again, the details of what these different metrics mean are beyond the scope of this video as well. Otherwise, the video will be very long. Down here is our confusion matrix. So you can see right here, these are all of our true negatives. These are our true positives down here. And then I think these are your false negatives and false positives. I sometimes get those confused. Don't quote me on that. Well, you can see we only made a mistake one time. So you can kind of see where this value comes from. 9 out of 10 gives you, 0.9. And then 9 out of 10 right here, when you add them together, gives you 0.9. You can kind of see where that number comes from now. And so we're doing really, really good here. But remember, one of the challenges with fraud detection is that random guessing will still be very accurate. And so that's where it can kind of be a challenge. But this kind of gives you a starting place. And so, we could try to look for ways to tweak and maybe get this to be almost perfect. But then you have to deal with concerns of overfitting your data. That can also be a challenge. And so, this model is probably, as accurate as you could probably make it without causing yourself problems. So let's go back and, conclude, wrap this up, review the material, and finish the video. So in this particular video, what we did is we used logistic regression to try to determine whether an individual case was fraud or not. And so, of course, we started by loading our data. We took a quick peek at it. We separated the X values from the Y values. That's just for the sake of the model. Then we created our training test sets. And so remember, we trained on 70% of our data, and then we used 30% for testing. And you have to have 4 different objects, a training test with X values and a training test with Y values. Then we, of course, created the instance of our model, and then we fitted our training data to the model, and then we tested it. So in other words, we took our model and we tried to predict it. We tried to predict based on our testing values here. And then we took a quick peek at our classification report and our confusion matrix. Now, one thing I did forget to mention is when we created our classification report, we are using our Y values compared to our predicted values. That's what's happening right here. This is something I forgot to mention. Same thing down here, our test Y values to our predicted. We want to see how those compare. And then after that, we take a look. Now, generally, once you use your test data, you cannot really keep repeating and reusing it over and over again. That's when you start to overfit the model and kind of break some of the principles of machine learning. This is why it's also important to be aware of cross-validation, which is something we did not discuss in this video, but can be very, very helpful as well. And so whether this model is good or bad depends on several factors. For example, how well is this model performing compared to other models? And what is the context in which this model will be used? Are we more concerned with false negatives? Are we more concerned with false positives, etc.? These are all external factors that we have to consider. Also, keep in mind the audience, the stakeholders. When you have to explain how this model works to them, can they understand and appreciate it? Again, the traditional approach maybe is a little old-fashioned, but for the most part, the average person can understand what's going on with a traditional approach where you're making rules. With logistic regression and more advanced algorithms, you might have stronger predictive power, but then people don't really understand what's happening under the hood, which could be a concern if there's a problem in the future. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you again for watching, and you have a great day.